We're going to look at what happens when you take two functions and do the four basic operations on them. What happens, we get a new function. So when we add two functions together, or we subtract or multiply or divide, we form a new function. So when that happens, the domain of the new function will consist of all the members of the domain of both the two functions that we either added together or we subtracted. So let's look at an example where we let f of x be 3x squared plus 1. And we're going to let g of x be, g of x will be 5x minus 7. So what we have here are two polynomial functions. One is a quadratic, which is also polynomial, and one is linear, which is also polynomial. So we're going to add the two functions together. So I want f of x plus g of x. So my new function will be called h. I'm going to add f of x, which is 3x squared plus 1, plus g of x, which is 5x minus 7. So when I add those two functions together, I get 3x squared plus 5x minus 6. So notice when I add the two polynomial functions together, I get another polynomial function. So we can talk about the domain of this polynomial function. The domain of f of x is, since it's quadratic, we know the domain is all real numbers. And the domain of g of x, which is linear, a linear function, we know the domain of that function is also all real numbers. So when we figure out what numbers do those two domains have in common, so since they're all real numbers, the domain of the sum, which is what we get when we add them, will also be all real numbers. So we remind ourselves that's how we write it. X is an element of the set of real numbers. Okay, so now we're going to subtract the two functions. So when I subtract f of x minus g of x, I get 3x squared plus 1 minus, and then I want to subtract the whole 5x minus 7. So when I'm subtracting, I have to be really careful. I have to remember to distribute my minus sign. So what I get when I subtract is 3x squared minus 5x. And if I distribute that minus sign, that's going to become plus 7, so it's going to be plus 8. So when I subtract the two polynomial functions, I once again get another polynomial. And we remember that the domain, so this is a quadratic, so I remember that the domain of quadratic functions is all real numbers. In fact, it's a good thing to remember the domain of any polynomial function will be all real numbers. So if it's linear, if it's quadratic, if it's cubic, quartic, the domain will always be all real numbers. Okay, so we're going to multiply the two functions together now. So I want f of x times g of x. So I want to multiply 3x squared plus 1 times 5x minus 7. So I know I can multiply these together. I have to do a little FOIL here, a little distributive property. So I'm going to get 15x squared, 15x cubed minus 21x squared plus 5x minus 7. So once again, when I multiply two polynomials together, I get another polynomial. This one happens to be cubic, but the domain is still all the reals. And you could look at the graph. Remember, it's going to do something like this. Cubic has in behaviors like that, but it still goes forever to the right and forever to the left. Okay, so now we're going to divide the two functions together. So we're going to put 3x squared plus 1 over 5x minus 7. And with the dividing polynomials, we're not going to try and simplify. We're not going to try and divide. We're just going to go ahead and leave it as a fraction. And we need to go back up to the first paragraph of the notes that states that the domain of a quotient does not include x values for which g of x is equal to 0. And so what that is saying is that when we divide, we're going to end up having a fraction. And so we have to be worried about the denominator because we don't want the denominator to be 0. So I'm going to go over to the side, or I'm going to do this in my head, and I'm going to say, what is going to make 5x minus 7 equal to 0? Well, it's going to be when x is 7/5. So what I want to say for my domain here, notice I'm not simplifying, I'm just writing it as a fraction. And then when I state the domain, I have to worry about the denominator. So I set the 5x minus 7 equals 0, whatever your denominator is, set it equal to 0 and say, well, when is that denominator going to be 0? It's going to be 0 when x is 7/5. So my domain should be every real number except 7/5. So we recall that we can easily use a not equal to symbol. And if we say all x values such that x is not 7/5, then that will take care of everything except 7/5. Okay, so a power function has the form y equals a times x to the b power, where a is a real number and b is rational. So a couple of examples of power functions are, we're going to let f of x be 3x to the 1/2, and we're going to let g of x be 5x cubed. So two power functions. Notice it's just one term. Power function is just one term where it's some number x to the some number. So your exponent has to be rational, so it's going to be a whole number or a fraction. Okay, so we're going to do the same thing. We're going to do f of x plus g of x, but I'm going to show you another notation. If I see it written like this, then that means that we still want to do the same thing that we did before. We want to add the two functions together. So writing f plus g of x is the same thing as writing f of x plus g of x. So we're going to add 3x to the 1/2 plus 5x to the 1/3. And what I remember is that I can only add like terms, and these aren't like terms. So this is my polynomial. So this is my answer. I'm sorry. This is my answer. I've got a power function plus another one. So we have to talk about domain. So the domain of 3x to the 1/2 would be greater than or equal to 0, because the x to the 1/2 is the same thing as the square root of x. So this is what we have. So we remember that the number inside the square root has to be at least 0. So we want to say the domain of this function is when x is at least 0. And if we subtract the two functions, then we do the same thing. 3x to the 1/2 minus 5x to the 3rd. And we recall that we cannot add those terms together because they are not like terms. And the domain is going to be the same because we have the same two terms in our answer. All right, and then let's talk about multiplying. This would be f times g of x. So we're going to do 3x to the 1/2 times 5x to the 3rd. And we actually can multiply these together because we can multiply powers together as long as they have the same base. So I'm going to say 3 times 5 is 15. X to the 1/2 times x to the 3rd is, let's see, I'm going to get x to the, and I'm going to add the exponents. So 6 over 2 plus 1 over 2 plus 6 over 2 is 7 over 2. So this is what we get. And when we talk about the domain of 15x to the 7/2, we need to remember that this number right here, that little 2, tells me what the index of my radical is. So x to the 7 over 2 means the square root of x to the 7th. So I'm still dealing with a square root. So I still have to remember that the number inside the square root has to be at least 0. So I want to say that x has to be at least 0. Move over to the side here. And lastly, we want to do f divided by g. Notice the notation. I could write f of x divided by g of x, or I could write f divided by g of x. Either way means the same thing. So I'm going to write 3x to the 1/2 divided by 5x to the 3rd. And in this case, since we have just one term, we can go ahead and divide these. I've got powers that have the same base, so I can keep the base and I can subtract my exponents. So I'm going to say 3 divided by 5 is 3/5. And I get x to the, I'm going to keep the base and I'm going to subtract my exponents. So I get 1 over 2 minus 6 over 2 is negative 5 over 2. So in this case, I'm just going to leave my answer as a power function. I don't have to simplify. I'm just going to leave my exponent negative. And when I talk about the domain, I'm going to once again remember that this x to the negative 5 over 2 means 1 over the square root of x to the 5th. So in this case, we would want to say x is greater than or equal to 0, except actually we don't, because this is the same thing as 1 over x to the 5/2. And so we don't want x to be negative because it's the square root, but we also don't want x to be 0, because if x is 0, then our denominator would be 0, and we know we can't divide by 0. Okay, so we talked about how we can add, subtract, multiply, and divide functions. Now we're going to talk about a new type of operation called a composition of two functions. We're going to do it in the next screencast.